Good day to everybody listening to me. This is Keith Klugman at the virtual ESPID meeting this year. I'm talking to you from a considerably cloudy Seattle in late September. And before I start, I just want to pay tribute to the rather awful milestone of today in the United States, which is 200 deaths from COVID, and COVID is literally, if not the elephant, at least the large virus in the room. I'm not going to talk about COVID, even though the Gates Foundation is hugely committed to trying to get vaccines available to the poorest of the poor and everybody on the planet. COVID in children, of course, is a small fraction of those deaths, although there have been 200,000 deaths in the US. They've only been reported to CDC up to the end of July, 121 deaths in children by a very broad definition of up to 21 years of age. And of those 121 deaths, only 15 are in fact related to this multi-system inflammatory condition. So children in terms of mortality are not a huge concern. Of course, they are a concern in terms of transmission, particularly older kids in high school and in college. So with that said then, the major contribution of COVID, of course, to mortality is going to be to interrupt existing vaccination schedules, and I will talk about that a little bit. I have nothing to disclose. At the Gates Foundation, we don't have any financial interest individually, and we don't work with companies in our individual capacity. So this is a picture of pneumonia mortality, and the news has been basically great for children. You'll see that for kids less than a year of age, mortality has dropped dramatically. In fact, mortality has dropped in all ages of the pediatric spectrum. And this is really good news. As I just mentioned in my intro, it is possible that COVID may turn some of these around. But it is also important, though, even though we're concentrating today entirely on children, to note that, in fact, pneumonia is increasing, and this is pre-pandemic in adults. And the two are linked, and that's why I'm mentioning adults as well. And the reason that pneumonia is going up as a cause of death in adults is that adults across the planet are aging, and pneumonia is a major cause of mortality as you age. So this is best described here in the second slide. And you can see why we at the Gates Foundation and the pneumonia program, which I lead, focus on sub-Saharan Africa and South Asia, because you can see the contribution of mortality in children in blue to pneumonia deaths, which is enormous in those two geographies. In high-income countries, as you can see further to the right, pneumonia mortality is really not a consideration, and the vast fraction of mortality is in the elderly, defined in this slide as over 70 years of age. When we look further at pneumonia mortality in children, there is a striking pattern, and this is pneumonia, and it does include neonatal sepsis. And you see that, in fact, this is all mortality in children. Pneumonia contributes 15%, which is at the top of this pie, the sum of 12% in kids over a month of age and 3% in neonates. But overall, when kids die, approaching 50% of all of those deaths are in fact in neonates. And so in my discussion today, I'm going to show how our interest in preventing mortality from pneumonia has expanded also to neonatal sepsis because of this increasing contribution of mortality in the first month of life. But this is just to say that pneumonia is still a huge burden, despite the fact that I showed that all-cause child deaths are going down, and pneumonia is a big fraction of those deaths. Still 5.3 million children under the age of 5 died in 2018. It was responsible, as I mentioned, for 15% of all deaths. And then this large fraction of deaths occurring, those deaths occurring in newborns. So what vaccines do we have to prevent, in general, deaths in children from infectious disease? This is all vaccines, and the important pneumonia ones here are the pneumococcal disease on the left, and you'll see the pneumococcus still dominates as the largest vaccine preventable cause of death in children. In addition, measles extraordinarily important for places where it has not been eliminated. Hib burden much lower than it used to be because of successful rollout of vaccine. And pertussis I'll deal with very briefly because the wholesale pertussis vaccine is in fact still reducing pneumonia mortality due to pertussis in the developing world. When it comes to the pneumococcus then, what is new and important? Well, we do at the moment have the 13-valent and 10-valent conjugate vaccines. These are the data, updated data from the CDC published in 2019. And you see this dramatic reduction in the serotypes and the disease burden attributed to the 13 serotypes, comparing 2013 to baseline before that vaccine was introduced, a 93% reduction in those strains in the United States in children under 5, and then this remarkable reduction across all age groups. It is by far the best way to prevent pneumococcal disease in all age groups is to immunize children. Children are the sentinel group responsible for spread, and you see on the right side of the slide, the cases prevented. So there are a lot of cases prevented in children because there's a lot of disease in children, but very little mortality. And so if you look at the lower right slide, you see that in a rich country like the US, backing up what I said earlier, although the vaccine is given to children primarily and prevents disease in children, the major fraction of mortality prevented is in adults. And these data go up to 2012, which was before the indication for the PCV13 given to adults in 2014. Now, in developing countries, there are some additional serotypes of the pneumococcus that are extraordinarily important, and you see highlighted in the red box on the left, serotype 1, which was in fact the 7th most common serotype causing invasive disease in South Africa. It was not in the top 13 strains in the United States, but was included in that vaccine by virtue of 2 trials, one conducted by myself as the PI and a second one conducted, that was done in South Africa, a second one done in the Gambia. So we are fortunate that the vaccine includes type 1, and you'll see the data on the left clearly show how in children under age 5, type 1 has virtually disappeared in South Africa, where the vaccine is given as a 2+1 schedule. The +1 is important because in the original trials in Soweto, South Africa, and in the Gambia, there was no booster dose given, and we clearly showed that the type 1 antibodies only protected up to about 18 months, and there was no protection thereafter. But it seems that with the booster dose at least, and there are some other data to show that even without a booster dose, provided you cover enough children, it does appear that transmission of type 1 may be reduced. And on the right-hand side, yet again, you see in the dotted line, the reduction in type 1 in South Africa in adults. The solid line is the reduction in less than 5-year-olds. So, so this vaccine works even for serotypes that are not routinely found in rich countries. Now, the schedule of pneumococcal conjugate vaccine globally includes a booster dose in most rich countries, but in poor countries and the so-called Gavi countries, a lot of them are not receiving the booster dose. We feel that it is important for longevity of response, and also because we're not seeing reductions in carriage in children to the same extent that are seen in rich countries. Recently, some of you may be aware that Australia switched from a 3+0 schedule without a booster dose to adding in the booster dose. Now, the UK is actually ahead of the rest of the world in that, having virtually eliminated the 13 serotypes, they have taken the approach to look at less doses. So moving from individual protection of young children, there were a series of studies. David Goldblatt was the PI. We did contribute funding from the Gates Foundation to show that after the booster dose, just a single dose, primary dose the first year of life, if it's followed by a booster dose in the second year of life, you can see top left here, the doses were given at 2 months and 12 months of age, that after the booster, you do not have a reduced immunogenicity. So it would be expected that the vaccine may contribute to continuing herd protection. This is not something we're recommending for introduction of a new vaccine, but where you have established evidence that the serotypes are no longer circulating, you may go down from a 3+1 to, in fact, a 1+1 schedule. Bottom left with the PI Shabir Mahdi, these data are, in fact, I'm not going to go in because of lack of time here, but in the Lancet Infectious Diseases in the last month is a publication showing exactly the same finding from South Africa, but this time using both the GSK and Pfizer products, so PCV10 and PCV13, that after the booster dose, a 1+1 schedule is equivalent to a 2+1 schedule. They also in that study randomized the first dose to either be at 6 weeks or 14 weeks. And there was some variability in the responses, but interestingly enough, just before the 9-month booster, the kids who got the vaccines of either vaccine at 14 weeks had higher levels of antibody across the board. And seeing as pneumococcal disease is not very common before 14 weeks of age, we would probably recommend a 14 weeks and 9-month schedule for those countries considering moving to this 1+1 schedule, which is under consideration at the moment in South Africa. The rest of the slide shows additional studies that are yet to report out publicly. Moving on then from the pneumococcus to consider this neonatal mortality rate, which you'll see in the bottom line here in red, has not reduced as fast as mortality in the older age groups. A brief consideration of maternal immunization for influenza. There were a series of large trials funded by the Gates Foundation in South Africa, Nepal, and Mali. And there is a meta-analysis recently published with good evidence in all 3 sites that vaccination of pregnant women not only protects the pregnant women, but protects their infants. The duration of protection, however, is relatively limited to only about 60 days, up to perhaps max of 90 days of life. And this is an issue for influenza because although flu is a major player for children less than a year of age, most of the disease is after 90 days of life. So it was interesting that in this analysis, which was a secondary analysis from South Africa, that the kids whose moms received flu immunization during pregnancy had a significantly reduced pneumonia hospitalization right up to 6 months of life. And that's an interesting finding, which I'm going to return to in a minute when we start talking about new vaccines and monoclonals for RSV. So it appears that if you prevent very early disease, be it attributable to influenza or to RSV in the first few months of life, you may actually reduce subsequent hospitalization for pneumonia up to perhaps in the case of RSV, a year of life. So let's talk more about RSV. RSV is a major killer of children. These are a series of studies that we funded around the world looking at kids who have died of all causes between a week of life, the first week of life, and 6 months of life. And what you see is the fraction of those children who have RSV detectable by PCR in their nose at the time of death. Now, RSV is not a pathogen in children this age, which you find very commonly in asymptomatic children. In fact, the positive predictive value of an RSV for disease is over 90%. So although we can't say for absolute sure that these numbers, if you look at them, Argentina, 11.1% of all kids, small sample, 5 out of 45, who died had RSV, but you see in Zambia, a much larger sample, exactly the same percentage, 11.6%, 60 of 517 kids who died of any cause had PCR positive for RSV. Similar data from India at the top right, Pakistan a little lower, but still between 5 and 10%. What is in the red in the slide is a fascinating large study being funded by the Gates Foundation looking at not only nasopharyngeal swabs, but minimally invasive tissue samples from children who have died. So this gives additional opportunity to look at whether the RSV was found in the lungs. And in that series of studies, you can see top left in the red bar on the left, that 8% of all the children who have been studied so far, so 29 out of 329 kids, had RSV detected, and that was assigned to have played a role in mortality in 6% of those deaths. So RSV is a major killer of children, and up to now, as you know, we have not had, aside from a very limited use, expensive monoclonal palivizumab, anything to prophylax for RSV. So in the last month in the New England Journal, 2 papers, both providing extraordinary hope for pediatricians globally to prevent RSV. So let's start off with the Novavax study. This is a maternal vaccine given to pregnant women. What's in the vaccine is the F protein of RSV. Unfortunately, the way that protein was formulated in the study was not in the so-called prefusion form, which we now know is more immunogenic, but nonetheless, that it did prove to show a proof of concept. So what we have in the top line is RSV-associated medically significant lower respiratory tract infection. This means there was evidence of a respiratory tract infection, and PCR was positive in the protocol analysis, which is shown here. The PCR had to be done in a specific lab with a specific assay. And you'll see that the efficacy was around 40%, with a confidence interval which went just below 0 for the 97.5% confidence interval, and that is because there was an interim analysis. So the 97.5% confidence interval was the one used by the FDA. 95% confidence, that same point estimate is significant. Be that as it may, it's reasonable efficacy. It is not enormous efficacy at around 40%, but for a common pathogen, that is important. When you come to severe hypoxemia, so pulse ox showed that the kids were hypoxic. You see here a similar reduction, 48.3% in the middle, but again, a confidence interval that goes below 0. If you look at hospitalized children, which is C, the bottom graph, here similar 44% reduction, but statistically significant. There are a lot of numbers in the slide here. The same per protocol analysis I've just talked about is at the top left here. But in addition, they did additional expanded exploratory analyses, which allowed things like a PCR that was not done in the one routine lab, but a PCR that was done at the hospital. And you see that, in fact, the point estimates of efficacy, if we look at the primary endpoint of it, in the top row, didn't change. 39.4 is the one that was the primary endpoint, the expanded one, 41.4. But because of the larger numbers, all of these exploratory endpoints are significant with lower confidence bounds above 0. So it is fair to say then that this vaccine proof of concept was there, but with modest efficacy. And there are next generation vaccines which are under development, which use the prefusion form of the F protein, which we hope will be more effective. Now, why the prefusion form is important is because it allows site 0 to become available to the immune response. And this is a picture of a monoclonal antibody directed to site 0 on that prefusion form of the RSV vaccine. It is a study that was conducted by MedImmune. You can see the name of the monoclonal, nirsevimab. And here, in a very similar population, but now it is the infants themselves who are given the monoclonal antibody with a long half-life. You see quite beautifully protection that is higher, up to 70%, and that is protection against medically attended RSV as well as hospitalization for RSV, in fact, and even higher efficacy with lower bounds that are way above 0. So this is very promising for a future where we should have 2 approaches to prevent RSV using the prefusion forms of the F protein, either a monoclonal or a maternal immunization. Very briefly then, I'm going to say just one thing about pertussis. As I've mentioned, the wholesale pertussis is widely used in rich countries. However, the secret to protection of neonates from pertussis before they get vaccinated is to vaccinate mom. And these are some really interesting data from a lovely baboon model of pertussis, showing in the left-hand column PT as pertussis toxin, for the first time a correlative protection for PT antibody. So what you can see is that where PT antibody was less than 2 micrograms per mil, which was in unvaccinated baboons, their infants, when exposed, got symptomatic pertussis disease, which is the red dots. However, when the baboon mothers were immunized, which is the black triangles, they had higher levels of PT antibody, and none of the infants got sick. Now, the other components of the acellular pertussis vaccine showed no such correlative protection. So it seems that PT antibody is the key antibody to protect from symptomatic disease in young babies, and that's why maternal immunization is very important. To conclude, I want to talk about 2 things that we are very passionate about at the Gates Foundation that we believe could impact deaths in children, this huge fraction of infant mortality. I apologize, of course, I now notice as this slide is shown that stillbirths is wrongly spelled here. But stillbirth is a huge issue, and we believe GBS plays a major role, and this slide with its reference clearly shows the huge burden of GBS globally, and you see the total of 90,000 infant deaths plus, because infant deaths do not include stillbirths, plus a significant fraction of stillbirths attributable to GBS. The largest burden of this mortality, we believe, is in Africa. So it is exciting to see in the last month these data published online just this month from Pfizer, who are making a 6-valent conjugate vaccine, which they are now testing in pregnant women in phase 2 studies. You can see that the vaccine is immunogenic, providing high levels of antibody to all 6 serotypes. There are still some questions about women who have low pre-existing levels of antibody, but this is a very exciting and sufficient data to go forward with the phase 2 studies, which I have just mentioned. Finally, in conclusion, there is a large problem of early neonatal sepsis due to antibiotic-resistant gram-negative pathogens, particularly in developing countries. So as kids are moved and births occur in facilities in poor countries, this is good for the babies, it's good for the mothers, there's less overall neonatal mortality, but there's a major problem in those hospitals of nosocomial sepsis. And you'll see the data in these 2 slides showing South Africa on the left from the CHAMP study that I mentioned earlier. Acinetobacter baumannii as the leading pathogen, Klebsiella second. That does reflect an ongoing epidemic in the major hospital, Chris Hani Baragwanath Hospital in Soweto, where the study was done in South Africa. Studies from the rest of the world, the CHAMP studies show Klebsiella as the leading pathogen. And you see on the right another study funded by us in the pneumonia team at the Gates Foundation called Barnard's, that 98% of the Klebsiellas in fact have only 4 O serotypes, And of the 77 capsular antigens, 81% of the Barnard's isolates belong to just 16 serogroups. So seeing as we are looking at multivalent pneumococcal conjugates, we are beginning to explore the possibility of a Klebsiella vaccine. At the bottom, you'll see we're also interested in Staph aureus. For the interest of time, I'm not going to talk about that. So here are surveillance studies. We need to know what the distribution is of Klebsiella serotypes. Globally, we are studying these. We hope to have whole genome sequence information of over 3,000 Klebsiella serotypes globally by the end of this year, or certainly by the end of next year. And we are beginning to explore interest in making a multivalent conjugate Klebsiella vaccine to be given to pregnant women to try and protect their infants from nosocomial Klebsiella sepsis in the first year of life, or first month of life. So in summary then, deaths declining in children, but pneumonia remains a major killer, as I showed, unacceptable number of deaths. Pneumococcal conjugate vaccines rolled out in many developing countries, reducing mortality, but we do believe that a booster dose may be useful, which is the innovation in dosing schedules in the next bullet point. I pointed out that more than 45% of deaths in children now occur in neonates, and we have for the first time a proof of concept either for a maternal immunization vaccine or an infant dose of anti-RSV monoclonal. Both GBS vaccines are in development now, phase 2, hopefully going into phase 3 soon. And then we are beginning to look in the preclinical space at a Klebsiella pneumoniae conjugate vaccine to protect infants when given to their pregnant mothers. So I would like to thank you for your attention and hope you all stay safe. Thank you.